Math review. Substituting numbers into equations. Part A. The equation for density is this. Density equals mass over volume. Now, what if we have volume and mass? Can we compute density? Well, we just need to plug in this number on top. This number bottom, mass over volume, is gonna be the density. We need to check the units, gram, cubic centimeter, and over here we have grams per cubic centimeter. So all we need to do is we have mass in grams divided by the volume in cubic centimeters, and we submit. By the way, the density of pure water at 4 degrees Celsius is roughly 1 gram per cubic centimeter. So this material has a much higher density than water. The equation for molarity, M, is this. M equals N over V. N is the number of moles of solute. V is the volume of the solution. We don't have to understand exactly what molarity is, what this moles mean. We just need to plug in numbers. Over here, if we have this equation and we are given the value of this uppercase M, 7.42 mole per liter, and also volume here, how do we compute N? How we can see from this equation, N is M times V. So we have M times V. The equation for photon energy is this. E is hc over lambda. H is a constant over here. C is the speed of light. I would put 3.00 here because I think C is equal to 2.9979 times 10 to the power of 8, and then we need to round it up. What is the lambda if we have the value of energy? So if you look at this lambda, we can multiply both sides by lambda, and then we have lambda times E equals hc, and then both sides divided by E. Lambda is equal to hc over E. Alright, that's it. Lambda is hc over E. So first you multiply both sides by lambda, and then divide both sides by E, and then we get lambda is hc over E. Alright, now we need to plug in numbers. We have H is 6.626 times 10 to the power of, you can type 10 and type shift 6. Alright, press shift 6 with that caret sign on top of 6, and then you enter negative 34 here, and then the speed of light times 10 to the power of 8. On top, I need to get rid of this C. On the bottom, again, we need to have the energy. Alright, times 10 shift 6 minus 19. Now we have this lambda. We do have to pay attention to the unit. We have joule and second for H, we have joule for energy, and we have meter per second for the speed of light. So on top you have joule second, and meter by divided by second, and on the bottom it's joule. If you look at all those units in the end, it's going to be meter, because joule and joule will cancel. Second and this per second will cancel, so in the end you have meter. Let's see if Mastering Chemistry will accept this. Alright, so we got this 4.3 times 10 to the power of negative 7 meters. Later you will see this is 430 nanometers, 430 nanometers, because 1 nanometer is 10 to the power of -9 meters. Part D. Another equation over here for the ideal gas. We have PV equals RT. P is the pressure, V is the volume, N is the number of moles of the gas, R is the constant, and T is the temperature. So given all those information, well, somehow we need to do the calculation. Alright, we need to do the calculation. Let's see, P is 899 torr. So we have a torr here. And I don't think we have a torr over here. Alright, so both torr and ATM are units of pressure. Alright, we need to do some conversion over there. And volume, we have milliliter here, but we have liter here. So both milliliter and liter are units of volume. We need to do some conversion over there. You know, here we have Kelvin as a unit of temperature and Kelvin here. So we don't have to worry about this Kelvin. Now, which of the following conversions would be necessary before you could find the number of moles in this example problem? So again, pressure. We have torr and ATM. Alright, torr and ATM. Torr should be converted to ATM, and then we can use R. Alright, and milliliter, maybe we should convert milliliter to liters, and then we can use this constant R. Let's see, from milliliter to liter. Well, it doesn't say milliliter, but it says convert the volume to liters. So really, this volume is 8.56 liters, because 1 milliliter is 0.001 liter. 1 liter is 1,000 milliliters. What about degree Celsius, degree Fahrenheit? We don't have to worry about it because we have Kelvin here and a Kelvin here. Okay, so we don't have to worry about the unit of temperature. They're the same already. And then we can click submit.